series of crimes in America.
Yo, can you guys hear me? Voltage, Mr. Protocol, Archbishop, Chris. Thanks for coming in. How am I sounding? Am I too loud? Good volume. Yeah, Chris, man, it's great to have you on. Feels like forever, doesn't it? No, what do you mean no tea? Yeah. You gotta have your tea. Time to get that Irish breakfast on the brew there, Archbishop. Man, can you believe it? It's been over a month since the last stream, hey? Can you believe it? 38 degrees. It's 30. Actually, it was a cooler day today. Lower than 30s, but I'd still would have my tea. But yeah, it's been over a month, actually. I think it was like the 17th or something since when I got on last, and there's been trips to Melbourne and a couple of weeks in Sydney for Corlan, and then work's been a bit hectic, and then Christmas-related stuff, and all of that sort of thing. So that's why I've been a little bit AFK as far as the streaming is concerned. But I thought we need to squeeze another one in before the end of the year, and here we are. So thanks for joining in. What I actually was thinking of doing was another Meterpreter dev stream and getting started on channels, because that's pretty much where we are. But I thought if this is going to be the last stream for the year, I don't really want to leave a massive gap between now and the next one if we're in the middle of doing some channels related stuff. So this time instead we're going to do more PicoCTF, have a bit of fun with some CTF challenges, and then wind things down. And early next year we will kick off more Meterp dev, and hopefully we'll get to a V1 on that before we reach 1 year's anniversary in April. That'd be good, hey? How are you guys doing? Did you bring your tea? Because hacking without tea is very uncivilized. Tonight's back on the dong ding. Sorry, I always get that wrong. I had a liter of Gaiakura earlier today, and I've smashed a lot of black during the day as well. So I thought I'd get back on the green, but I felt like an oolong. And while I'm at it, back to the 90%. Lint. So, bring your chocolate, bring your tea. I'm just going to quickly smash on one of these. Have a lovely jug of ice. Welcome out, Wolf. It's good to see you, mate. I hope you're doing well. Thanks for coming on, man. Everyone be good to At Wolf. He's had a rough week. That's good to hear, man. So, excited? We'll do some CTF challenges. I'm in the mood. Should be good. We've got some of the regulars on board. Yeah, I reckon. Alright, so I will move my face up to there. And let's kick off, shall we? Now, I don't even remember what it was that we did last time. It may well have been... Oh, it was this last reversing one, wasn't it? We solved this reversing one. So now what we need to do is move on to the next one, which is another forensics challenge. This program was about to print the flag when it died. Maybe the flag is still in this core file that it dumped, also available at problems. Okay, right, so this isn't just a classic sort of forage through, I don't know, a PCAP or something like that. It may actually be interesting because it's binary. Insolent, welcome, sir. Hope all is well with you, mate. All right, so let's go into forensics and we'll do this and we'll grab the files. Copy link location. And we need the no check certificate thing, don't we? And we'll grab the program too. Copy link location. Get no check certificate. I wish I could set that as a default. It probably can set it as a default, right? You can see I was in the middle of updating. Okay, so what are we doing? We want to go stream, PicoCTF, forensics, core. Okay, so that core file is, it's an elf. And print flag is obviously the binary. So, okay. Let's make print flag executable. Now, isn't there, there's some GDB. That's a very good idea, Atwolf. I should do that. I should set that as an alias. So, I think when we run GDB, can we can specify the core, right? And GDB. Can we pass that as a parameter? Where are we? Prog. Ah, okay, there we go. We can pass it in on the command line. So I assume then we can go GDB print flag core. Okay. So what do we got? I actually haven't done this for a very, very long time. Debugging or getting stuff out of a core dump. So what do we got here? We got couldn't load shared library, yeah, whatever. What do we got here? Program terminated with sig trap at print flag at printflag.c line 90. Obviously we don't have printflag.c. So I assume then what we would need to do is see what functions. Oh geez, there's a crap ton in here, isn't there? Maybe we can go info function print flag. All right, so we've got, there are symbols obviously in here. Okay, so we can go disas print flag. Ooh, I don't know what I did there. Okay, so somewhere in this function, it bailed. So what was this function doing at the time? What do we got? It looks like, what do we got here? Dword point. Okay, so we're storing a local variable, a value of hex 539 into a local variable. And we move that into EAX. And then we times it by 4, add a fixed address, dereference it, shove it on the stack, and shove a hard-coded address on the stack, and then call printf. So this would be a format string. So can we do this? Aha, okay. So we're actually in the middle of printing something when it died. Wolf isn't a mod? Yeah, he should be a mod. He is a mod. Alright, so that means that if this is the format string, then EAX right there and then at this point here should be the pointer to the first parameter, which I assume would be the flag, right? So if we copy this, actually we don't want EAX, we want 539, don't we? So if we go print OX5539. Okay, so there'll be an address in here, right? We want to dereference that to get this. And then I assume we want to print the string that's here. Is that what we're doing? I think that's what we're doing. It gets the value and dereferences it, and that's what we should print. So it should be PicoCTF with this in the middle of it. Yeah? You guys are great. Alright, so if that's the case, then it should be PicoCTF with that in the middle. Was that it? That was it? That was surprisingly easy. I thought I was doing something naive or stupid there, but hey, that was pretty easy, hey? Winning all the things. Okay, what do we got next? We got a binary. Gee, I hate binaries. Not. Okay, let's go got shell, cd got shell. Can you authenticate to this service? Oh, actually last time we did this. Classic OJ. Classic OJ. The streamer is a jerk sending photos of fun while you're working. That's very true. Let's just make sure that we can connect to this because... there we go. I'll let you write one 4-byte value to memory. Where would you like to write this 4-byte value? Interesting. Bogum MG, welcome. It's good to see you, mate. And Barney, as always, it's good to see you too, buddy. Thanks for coming in. Let's copy that and wget no check. And we'll grab the service. Wget no check. What have you guys been up to anyway? It feels like forever since we've spoken. Slickus, welcome. Yeah, long time no hack. I agree, man. It's been a month. It's been too long. Yeah, well, that's the thing, hey. That no check certificate is just awful. Getting Splunk certs, eh? Rip. A little bit of hack the box. Yeah, nice. What was that one called? Was that called... Got Shell. That's what it is. I'm hoping this one's going to be fun. All right, let's chmod that, and in the meantime, I'll have a look at auth.c. So what do we got here? I will let you write one 4-byte value to memory. Where would you like to write this 4-byte value? Okay, now what value would you like to write? Okay, writing. All right, so it's reading 2 hex numbers and literally writing and then calling exit. One would assume that I can just use puts, given that puts will be sitting in the GOT, right? So if we look at auth, GDB auth, disas main. So this puppy here, is it here? I think it's here. PLT, we want puts. We want to basically overwrite what's in here with a reference to win. Okay, that'd be right? Info function win. So we basically want to overwrite this address with this value. Does that seem reasonable? I'm pretty sure that's all we need to do, right? Let's exit out of that and grab that NC that we need. Let's see what it says. So we want to go, I'll let you write. We want to write to this. And the value that we would like to write is the address of win, which is this. Okay, maybe I need to do it faster. The monitored command dumped core. Le breadstick, welcome. Chris, the command that I just did here, this x16wx, is a built-in. So that basically says I want you to, x is dump memory. The slash basically is a separator for how you want to dump it. And so what I'm saying is I want 16 words in hex format starting at this address. So that's dumped 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You can do x-s, which says print out a string, and it'll try and treat it like an ASCII string. You can do things like 16 bytes, so bx will do it as bytes. So you can kind of print out things in different ways. It's pretty cool, super handy. But clearly I'm not doing the right thing here, right? So maybe I should just run this and do the things that I want to be doing. Okay, so what is this doing here? Moving, okay, so EDX contains, okay. This is what I want to change, right? So, is that, yeah, that's what I want to change, this value here. Because this is in the GOT. Okay, so I was trying to change the PLT, not the GOT, so that's pretty dumb. So I want to write to this value here. Okay, so if we do that again, we want to write that, and we want to write this. There we go. Cat flag.text, and there it is. Does that make sense? Does everyone know exactly what we just did there? Pretty simple if you know how the GOT and the program linkage table and everything works. Have any questions? Take a sip of tea. That wasn't so bad, eh? Now, what should we do? I think I missed some of the start, but I assume you overwrote the GOT. Yes, that's correct. That's exactly what I did. So, whoops. Press the wrong button. Let's go. So what I did here, I had a look. I actually started by writing the address of the PLT, which was pretty stupid. Inside here is instructions to jump somewhere. So this is what I needed to, because that's basically where we were going to be jumping to after puts was called. And so I grabbed this address and I grabbed the address of win, which we had up here, and basically wrote win over the top of this address in the GOT, and got shells. Yeah. I love shells. Shells never get old. What is win doing? That is, let me show you. .c, win just gives you a shell straight up. Yeah, it's just doing a system call straight for us. Pretty cool. All right, what can we do? We can do another reversing one. We can do some ropping. What do you guys feel like doing? We've got another forensics one coming up. Malware. Ugh. Should we do this reversing one, or should we do the ROP chain one? Yeah. I know, right? Triggered. So. No malware? I don't want to do the malware one. That's forensics. I'm so bad at forensics. Just keep going in order. I agree. Let's do that. Okay, so we need to go back up to reversing. And we need to do quack me up. Oops. Quack me up. I get the feeling this is going to be very similar to the other quack me. Copy link. Okay, so can you quack this program as well? Oh, you get no check certificate. Okay. Binary. What have I done? It's not binary, is it? It's reversing. Quack me up. Of course, it's a binary, isn't it? It is a 32-bit. Chmod plus x main. What does it do? We move along swimmingly. Is this one too foul for you? Enter text to encrypt. Text to encrypt. Now quack it. Ugh. Really? Is this going to be a crypto challenge? What do we do? GDB? Let's have a look. Decides main. So, read input, encrypt, print hex, printf. I assume that it's using a key of some kind of memory to encrypt stuff. Let's see what encrypt does. It's another recursive caller. Rotate right 8, rotate left 4. Call. Okay, so it doesn't do it. It's itself. Yeah. Okay, so what it's doing is for each character, 106. That's where it bails. What are we doing here? We get given 2 parameters. No, we don't. I assume we're iterating over stuff. Hang on, let's do this. Let's break just here. Righto, so the string length is 7, which is correct. And then what are we doing? We're taking that value and shoving it in a local variable and another one in a local variable. And then we're just going to the end, which says read that count. I assume it's a counter, and compare that to how long the string is. And if it's less, we go back to where we were before. So we're going to start iterating over the string. Read out a reference to the string, add... What are we adding? EDX, which is the current offset. Moving the character into EAX. And then storing that in another local. Moving that with sign extend. Pushing that onto the stack and rotating that left. So I assume this should turn into what, 4-5? Yeah, there we go. EAX turned into 4-5. Okay, so we then move that back into whatever that local was. We XOR it with 16 and read it back out. And then what do? We rotate that right by 8. Really? Does that doesn't do anything, does it? No, it doesn't. So that's effectively a NOP. Unless it's a sign extend. Oh no, sign extend won't do anything. Yeah, sign extend will do something. Okay, so stick that back in the local. Read out the current offset. Read out the... What is EAX? The string again. Add the 2 together. Read the value that we've just stored. And then stick it back over the top. Okay, so that means that we are, as we can see here, we are XS. We are slowly overriding the key, or the text that we had overwritten. So that's a bit of a no-brainer, isn't it? That's just going to keep doing the same thing. Yeah, this is really not that interesting. Okay, so question is, what happens when it finishes? Let's have a look. Where's the end of this function again? Leave ret. So let's do a break here. And continue. And let's see what's here. Okay, so that's... We know it's 7 characters, right? So let's just have a look at what those bytes look. T-E-S-T-I-N-G. And that's what we ended up with. Alright, so we step out, and what does that do? That's going to print something to screen. Where is it? Here's your ciphertext. Okay. Call print hex. Yeah, okay. And so that spits that out. So I assume that's telling us, you know, one direction, but we actually need to go in the other direction for each character, right? So that's not particularly tricky, assuming that we just need to do the reverse of what we've got here, which is probably quite reasonable. Actually, I didn't need to do that. Yes, I did need to do that. CD stream pico reversing quack me up. Okay, let's just touch solution.py chmod plus x solution.py. Let's go open that up down here. User bin and Python 2, come at me haters. I'm just going to convert this to a byte string directly. Or just go cipher equals. Is everyone still with me? I'm pretty sure we can just go replace spaces with nothing and then decode it as hex. Print. Let's just print that out. You lost me at Python 2. Yeah, sorry. Okay. So what we need to do is the reverse of encrypt. So let's just quickly look at that again. So what we do is we rotate. What do we do again? We rotate it right by 4. Sorry, left by 4. We then rotate right by 8, which is effectively a not because we're only doing a single byte. And then we XOR it with a hard-coded value of 16. Oh no, we do that first. So all we need to do is the reverse of that, right? Correct? So basically what we need to do is we need to XOR each character with 16, and then we just need to flip the 2 bytes. So let's go def roll write 4 bytes of a character. Should we assume that we're dealing with... We should assume that we're dealing with integers probably, right? So we want to return C shifted 4 or C and OXF shift it up 4. Yeah. So then we can go we want to go raw 4. Oh, we also need to XOR it, right? We'll just call XOR a character with a value, and we'll return C XOR value. It's probably unnecessary, hey? So what we want to do is roll right 4 of whatever the character is, which is going to be odd of the character that we're mapping over. XOR'd with 16. It is 16, isn't it? 16 hex. 16. So rotate that right 4 for C in cipher. And then we should be able to join that together. Print it. Is it that simple? No. Sequence item 0 is expected string in found. For C in cipher, odd C. What have I done wrong, people? Accidental mistake. Yeah, so going backwards, right? We've got this XOR first. And then it says roll left 4, so we're going to... I mean, rolling left 4 and rolling right 4 is exactly the same thing, given that we're dealing with bytes, which are 8 bits in size. So what am I doing wrong here? RO4C. We're saying here that sequence item 0 expected a string and we were given an int. Correct. That's what I need to do. We need to convert it back to a character. Thank you. Silly mistake. Look at that. There it is. It just spat it out. It's like it wanted us to have it. Thank you for that. That was a silly mistake, wasn't it? Solved. Well played, everyone. Well played. Back to the binaries. Rot chain. We've got the source as well. Hopefully this will take a little bit of time. wget no check. So we grab the file. Let's have a look at the source as well. No check certificate. Okay. Teamwork for the win, people. Binary ROP chain. Who doesn't love a bit of ROP? Hey? Yeah, I do it all the time. Ah, look at this. We've got win function 1, we've got win function 2, we've got flag. Okay, so we're going to need to create a file called flag.txt. So let's cat into flag.txt and we'll go PicoCTF. This is where the flag goes. Righto, so we need to win 1, we need to win 2, and we also need to check that this argument is set to this. Okay, so this is a classic ROP challenge with some simple stuff in it. So what we can probably do, have I got Ropper installed here? Yeah, I do. Ropper file ROP. That should spit out some interesting stuff. Is it no color? I like to cache this. Where is the no color? No load. Ah, no color, one word. And we'll shove that into gadgets.txt. Seems fair. Professional hackers just use grep. Do they? I'm clearly not a professional hacker. Okay, so these are our ROP gadgets, which you probably won't need, strangely enough, now that I come to think about it, because we're just going to be putting the address of these functions in. So gdb gdb main, no, what's it called? ROP. Okay, so we want info function win. There should be a few here. Right, so we need win function 1, win function 2, and we also need function flag. So they're the symbols we need. And what we need to be able to do is construct a chain or a buffer that splats over the top of the stack with win function 1, win function 2, and flag. Good thing is there's no crazy bytes or anything in here. I got an emote thanks to Barney of the Rubbles subscription. Thank you, Barney, for the sub. You are a legend. That's cool. That emote's wicked. Okay, so we're just going to set up a very, very simple ROP chain. The question is, how do we invoke it? Starting program, permission denied. Okay, let's add +x to ROP and run it. Yeah, so we will need to automate this with Python and PwnTools. Does that mean we need to run this on the server in order to get to it? I assume it does. You can find the problems. Yeah, okay. So let's just open up another SSH to here. And we will cd. Actually, no, we won't. We'll go to a temp folder. Cd make temp d. Now we're going to have to do some Pythoning, right? I'm pretty sure that redeemed highlight. I'm pretty sure we'll need to use PwnTools again. Let's just go. What version? Python 2. There you go. That's why we all use Python 2, right? Touch solution py chmod +x. Okay, hashbang user bin env Python 2. I'm pretty sure that PwnTools is installed in here, so import pwn. And we want to go p equals pwn.process this thing, and it's ROP, isn't it? p.interactive. Yeah, cool. Excellent. So in here, we basically need to put the addresses that we dug out of this thing. Copy. Shove them in here. Oops. What did I do wrong? Let's do that again. There we go. Pardon me. Righto, so let's cut this stuff out. That's what we want to do. Oops. My Vim Foo is letting me down. Okay. So these are all addresses. Okay. Hello, Mugu. Welcome back to the stream, mates. Good to see you. I don't think you'll ever be able to use get system again, Barney. Those days are gone. Rip. Hit F to pay your respects. All right, so what we need to do before we continue, we need to figure out how far until we hit the end of the buffer, right? So we should be able to go, let's go buff equals pwn dot util dot cyclic. Give it, is it 100? And then we go p dot, let's just get everything. And then p dot send line buff. I just want to see if that would actually kill it. Module object is not callable. Oh yeah. I think I've got to go cyclic twice. Yeah, there we go. So what I'm going to do, instead of sending that to the program, I'm going to print it out. And we'll manually add it in GDB. I'm not going to go through the process right now of automating GDB with Pwn tools. But let's just go... where's that path again? GDB that, and we want to put this in. Man, get? What do you mean get? GDB. So we run, punch that in, it should crash. Info registers, you can see that EIP is here. I'm pretty sure all I need to do now is cyclic find, right? Is that how it works? I'm pretty sure that's how it works. Okay, Vim. So we're going to go SRP offset, so the offset to the save return pointer. We're going to put something else in here, by the way. Let's just go print pwn.util.cyclic find. Hopefully it will. Oh, man, I just can't type. 28 bytes off. Okay, cool. That's what we wanted to hear. Righto, so we want to go 28 bytes in. So we don't need any of this stuff anymore. We can just start with an empty buffer. And then we'll fill it with A's, do the old classic filling with A's until we get to the SRP offset. Then what we want to do is we need to set win1, so we can go, we want to return directly to win function 1, which takes 0 parameters, yeah? So we want to go buff plus equals pwn.p32 ADR win function 1, right? Now the return address of win function 1 should be to win function 2. The return address of win function 2 needs to be the address of the flag function. Now, what we do need to do here is win function 2 will expect a parameter according to this. So the win function 2 needs argcheck. We need BAAAD. So we need to take this and stick this on the stack immediately after the address of the flag. P32. Okay, because that'll be the argument for win function 2. And then after that, if I am correct, we need to specify the argument for what's it called? What is the argument for the other one? Dead bad. Okay, so let's just see what this does. Buff plus equals clone.p32 dead bad. Now what I'm going to do is I'm going to print that buffer out in case we need it and we can test it locally. Okay, so flag file is missing. Right, okay, so interesting. Our current working folder is wrong. Otherwise, I think that would have worked perfectly. So let's just, let's do this. Import OS. OS dot change working directory. Oops. Oh man, I'm hopeless. Okay, so let's change to this and then hopefully it'll work. CWD the function? I don't think it is. Clearly not. Python change working folder. Get CWD. Oh, it's Chadir. Such a noob. CWD. Where did I get CWD from? Well, there it is. Crushed it. CTF. Submit. That makes sense? Did everyone see how that worked? I'm sure that most people here are familiar with some ropage. Yep. Should I delete that? Probably should. Okay, some cool tunes here. Okay, that was cool. We're back to a forensics one. All right, see you, Mitch. Have a good one, mate. Thanks for coming on. If we're going to dive into another forensics one, there's two things that I need. The first is another slice of chocolate. The other one is help from you guys. So make sure you're paying attention and carrying me through this challenge because I am terrible at this stuff. Silverly Zero, hello. Thank you for coming on the stream. All right, what have we got here? Our PNG, really? This is what I hate about forensics. Go dig arbitrary crap out of the PNG. All right, what do we got? Malware shops. Oh, didn't paste anything. Whoops. Is everyone looking forward to the end of year break? Has anyone got anything interesting planned? Going away? Hanging out at home and just chilling? Oh, awesome, Sylvie. That's awesome. Thank you very much for investing the time and for joining in. It's lovely to have you. Sing out if you have any questions, man, or sing out if you have any ideas, because I'm hopeless. Yeah, that's it, man. Me too. I'm going to be, over the break, my primary focus is rock climbing. And then secondary, I'm going to be doing, probably going over some more core land stuff like De Life D. Hang on, I've got to get closer. De Lil D. Just like them. I'll be playing some Rocket League. I'll be playing Beat Saber with my kids. And I'll be running and hanging out at the beach. It'll be awesome. Rock climbing, to be fair, is probably my main thing every day. Yeah, that's fair. Where you based, Silverly? And D Little D, which call and advanced did you do? Ah, yeah, Silverly, that's right. I know who you are now. Yes. Yes, excellent, Sydney. Sorry, it took me a while to connect the dots. Haven't Pico challenges to get. Yeah. Right, fair enough. Anyway, where are we? We are in, and we need to go to forensics, malware shops. Yeah, my bad, dude. There's a lot of names, and I always struggle to connect names behind the scenes. Yeah, I'm just a jerk. Just a jerk. You know that already, though, right? Alright, what does info.txt have to say? You've been given a data set of about 500 malware binary files that have been found in your organization's computers. Whenever you find more malware, you want to be able to tell if you've seen a file like this before. Binary files are hard to understand when code is written, and there are several more steps before it becomes software. Yes, that's actually true. Some parts of this process are compiling, which turns human. Okay, yep, we know that. Assembling, which turns assembly code into machine code. Yes. Malware binary files that were given to you to analyze are all in machine code, but luckily you were able to run a program called disassembler to turn them back into assembly code. Disassembler. Assembly code contains instructions, which tell a computer how to update its own internal memory. Yes. And its progress through reading the assembly code itself. For instance, that jump instruction means jumped to executing a different instruction. And the add instruction means add two numbers and store the result in memory. Your dataset contains data about how the malware files, including their file hash, which serves as a name, the contents of the jump and add instructions. Malware attackers often release many slightly different versions of the same malware over time. These different versions always have totally different hashes, but they are likely to have similar numbers of jump and add instructions. Really? Okay, so... Oh no. This info is a little late given previous challenges. So... Yeah, this is one of those really shit, like interpret something from a graph kind of shenanigans, right? Is that right? What does this thing say? There has been some malware detected. Can you help with the analysis? Okay, so I've got... this is another one of those, tell me what shit you... let's give it a go. We'll give it a go, and if it takes too long, I'm just going to bail. Yeah? Okay, so let's move that under here so that we can see it a bit more. This is gross. How many attackers created the malware? You'll need to consult the files clusters.png. Well, that's not what it's called. We'll give it a go. How many attackers created the malware in this data set? This is exactly the kind of challenge I detest. I don't even know what I'm looking at. So, yeah, that was kind of rhetorical. But, yeah, gross. They should have used Splunk. They should have used Splunk. Okay, how many attackers created the malware in this dataset? Dataset is malware included in their file hash, which says the name of the cast. Malware attackers often use many slightly different versions of the same malware over time. So it'd be something as simple as like subtracting the max from the min. Yeah, group by length of the bar. What do you reckon? I reckon we skip it. I hate this shit. I'm going to do that offline or something. But those kind of things suck. Okay, so we're down to... We've got a reversing one. We've got another reversing one. We've got a web exploit one. Just set it on fire. Yeah, I agree. Yeah, no, I hate forensics, Mugu. Trust me. So, should we do the next reversing one then? Can you find the password to Radix's login? Should we do this one? Happy to do this one, or do you want to go to assembly 3? I like the assembly ones. They're actually really easy. We've got a web exploit. We haven't done web for a little while either. Cast your votes. Wolf said do them in order, but now he's reneged. Anyone? Just the next one? Radix sounds fun. Radix it is. Reversing victory. Radix. Radix is terminal. No checks to be it. Alright. It's pretty ordinary, isn't it? Reversing Radix's terminal. Okay. So I assume this is another, classic 32-bit reversing challenge. Pick anything, which everyone and no forensics. Yeah. Do forensics first. No. Alright, so what does this do? Please provide a password. Incorrect. Alright. GDB Radix. We're only an hour in. Levitating desk. Well, I can. Hang on, what I should do is this. So in some ways my desk does actually levitate. You're going to have to provide some context around here, Barney. Hang on just a minute. Let me show you. Okay. So my desk does levitate, but not in the way that you want it to. It's a standing desk that goes up and down automatically. So it is levitating. My stream crashed your TV. Excellent. So there you go. That was my desk levitating. But to be fair, the the context around that is to do with a recent tweet. Feel free to share the link, Barney. I love it. It's fantastic. I could even go and get the picture and show you guys. I'll do that in a minute, but let's carry on. Let's focus. Right, so we have a check password function. That seems legit. Clearly you can see here like we're grabbing something out of argv, passing that into check password. Check password. Ooh. Oh dear. That looks gross. Thanks, Barney. Might want to go back to the console's view. Oh yeah. Thank you. That's better, isn't it? Sorry, I was typing stuff in and I didn't realize that I had not changed my view back. Thank you, Apple. Okay, so I did disass main and we can see that we're just invoking check password with argv1 effectively. And here you can see it's doing a bunch of munging. And then at the end, it's doing a string compare with this. So I assume if we do this, so pushing EAX. So let's just break on this for a sec and run it. Run password. Ooh. Okay, so I assume that's the encoded version of what we did, and this is what we should be passing in. This, I mean, when I see equals at the end, I can't help but think it's base 64 encoded, right? At Wolf, back then the monitor count was actually accurate. Yeah, I had 4. These days I'm down to 1 ultra wide. So yeah. Yeah, are we just base 64 encoding? Let's have a squiz. It does look very base 64 encodey, doesn't it? Let's go echo pipe base 64. Really? Wow. That was pretty weak. Okay. That makes me sad too. When you see an equals, you're like, oh, that's base 64, right? Whew. That was a lot of downloading for very little. That was 400 points. Yeah, late. Anyway, we're off to something a little more interesting. Copy link location. I like these ones. You guys don't like them, but I like them. Reversing. Make direct. Oh, we just did a reversing one. What do we got here? Assembly 3. What do we get? Ooh. No check certificate. Righto, let's have a squiz. Now the question is, what does this return? Submit the flag as a hexadecimal value. Note your submission of this question will not be in the normal flag format. Okay, let's duck over here then. Quit. What was this? Assembly 3. Cheating. Okay, so this is what we're calling. So we're calling assembly 3 with these 3 values. Righto, so let's see what we got. We move BC into EAX and then clear it. So EAX is effectively 0 now. We then move EBP plus 9. Now, I can always fail. EBP is the base. We've got the parameters underneath that. So 1, 2, 3, 4. What is EVP plus 4? That's where the arguments start, right? So the arguments start at 4. So that would be 4 bytes passed to get to the first byte of this parameter, which would be A5. And then we add another 1 to get to D6. Am I right? So that'd be AH equals D6. And then, what does SAL mean again? ASM SAL instruction. Used to shift the bits to the operand destination to the left by the number of bits specified. Okay, so SHL is the same as SAL. I didn't know that. Shift left. Okay, yeah, it's exactly the same. Shift left. Righto, so we shift AX left by 16 bits. Am I right in thinking that given that we're dealing with AX, that would just take this value and wipe it straight off the side? Hello? Everyone with me? So we end up here, right? We've got, so EAX equals BC at this point. That's the whole value in AX. At this point, we end up with AX setting 0 because the only byte that was set was BC, and then we clear it here, so EAX is fully 0. No, that's not the point. We're doing this in our heads like we always do, Mugu. And so I would assume that we go through the 4 bytes. 4 bytes. Yeah, so it's that second byte in there, right? D6. So D6 gets put into AH. BC EAX. So at this point, EAX equals 0000. D600, right? And then once we do this, what this is dealing with is AX, which is that, right? So it's shifting it left by 16 bytes, and then EAX becomes 0 again. So if that's the case, A, B, C, we should be taking A, B, C. So this should be 23. So that is effectively minus 23. EAX is minus hex 23. Yeah? Whatever that happens to be. 1, 2, 3, 4, 5, 6, 7, 8 minus 23 is that. And then we take the next byte, which is D2, and we add that value to FF. Righto, so OXFF plus OXD2. That will give us D1. So we end up with FFFF, D1 DD. And then we get 16 bytes in D, E, F. We basically take those two, the last 2 bytes, E, C, D, E. So we take this. There we go. We take this value here. That becomes F1. Sorry, D1. And then we XOR that with... Actually, we only XOR this, which is exactly the same thing, right? With... What would it be? EC... OX, ECD... ECDE. And hex that. Does that seem right? What do you guys think? Did anyone hear the quantum processor? No. I'm going to take a stab and see if this is it. Confidence is not high. That is incorrect. I'm pretty sure I mucked that up. So I don't like pasting this stuff into C because it's not a reversing challenge then. It's just a... Oh, hang on a minute. Did I do that in the right order? Yeah, I did. Yep. Okay, so EAX to begin with has BC in it. Then it's cleared completely. Then we get the second. We just got to make sure that these offset's correct, right? Oh, hang on a minute. I did something dumb. Sub AL, not sub EAX. So EAX is not minus 23. We only end up with DD. And then we add. Okay, that's my bad. So we had 23. So we add D2. So we end up with D2 and DD. Right? So we end up with OXD2DD, and we XOR that with ECDE. Oops. Is that what it should be? No. What have I done? What have I done? This can't be this hard. So we subtract. Yeah, that's right. I'm pretty confident that that's right. We end up with just DD. That's minus 23, right? Assuming that our offsets are correct, right? Because EBP plus 4 takes us here. Plus 8 takes us here. Plus 12, which is C, takes us here. Someone needs to sanity check what I'm doing here, right? This AH gets set to this D6 value, but this wipes it out because it's a shift left. It's not a rotate left, it's a shift left, which basically just gets rid of it. We end up with 0. So that's minus 23 because we're subbing that from what is now 0. Line 12 will for only C, right? Line 12. No, it's the least significant byte, so that's still only 1 byte. Remember? So AL is BC. So that's setting EAX to 0. Then we set AH and we end up with that. We then shift it all out because we're not dealing with EAX. We're dealing with AX, which basically just slides that off the left and we're left with 0 again. We go minus 23, which gives us DD in AL. We then add the next byte, which according to this is D2. So we have D2 DD. And then we XOR that with the next 2 bytes. Do I need to do it the other way around? Is endianness biting me in the butt? It's probably, am I doing endianness stuff silly? That's going to be wrong. What do you think? We could emulate this, obviously, in Python. So the thing is, this is about understanding the instructions, right? Maybe I've just got my offsets wrong. I don't think I've got the offsets wrong. D, E, E, C. Have I lost everyone? Am I flying solo? This is depressing. I'm usually pretty good at this. Emulation in Python still means you understand it to some extent. Yeah, agreed. The thing is that I'm fairly certain that what we're doing here is correct. It's just a question of my offsets being wrong, right? This is effectively just one thing I'd like you guys to confirm, right? Is EBP plus 4 is the first argument, because EBP is usually the is that right? Or is it plus 8? Maybe that's my problem. Maybe I need to be doing, so instead of 23, maybe I need to be doing A5. We get 5B. Oops, I can't type tonight. And OX. So we end up with 5B here, but again, that just disappears. So maybe we just need to, yeah, we need to do it, maybe ignore this, and this is where we should be looking. So that becomes minus, so when we do this thing, yeah, it is, it's 5B, like what I was doing before. So that's 5B, and then we want to add whatever the next one is, which is D6. So OX D600, because we are adding it to AH, which gives us that. And then we need to XOR this with, which value is it? And do I have ND in this correct? If it's the next byte, it's got to be B9 8D. OX B9 8D. Yeah? Is that what it should be? Nope. I'm feeling rather stupid. It's not that either. Sanity check, people. Talk to me. What am I doing wrong? Le breadstick. I'm sure you're looking at this going, you're doing some stupid stuff, OJ. So what is it? What is it I'm doing? Any ideas? Endiness? Yeah, I'm thinking about that too. But again, I mean, if we take these bytes, we start here, right? The question is that plus 4 or plus 8? And then we read in that direction. So I would have thought 8DB9 was what I was... Oh no, but it's written in that direction. So if we interpret this address as a D word, then it's 8D. It's B9 8D. It's got to be that one. D2 D3. Oh, it is that one. Oh man, is this anonymous gifter going bonkers again? Who is it? Man, this happens every time. Okay, so we did a little D. So it was this last thing. So I was right the first time around. D2 word EBP equals D223. So, oh, it does it. So my offsets were wrong. Really? Ah, that's interesting then, isn't it? Who is it? Who is it? Come on, someone on stream is being that guy again. Okay, so you're saying... Yeah, that makes sense actually. So if that's the case, and we interpret that, then D is 2 bytes in. Yeah, okay, this makes sense to me then. Okay, so that means, like, ignoring all of that stuff, because that's just noise, this is where it starts to matter. So byte pointer, EBP plus C is, we start at 4, 5, 6, 7, 8, 9, A, B, C. So it's definitely there is where it starts. Thank you for the sub, B-Man. Very kind of you, mate. So D little d, you said that is D2 23. One less would be down to 23, right? Oh, hang on. No, it is the other way. I am getting endianness messed up, right? So when we write this value to memory, the first byte that's written is 00, right? The second byte is 21. Third byte is A4. Fourth byte is BD. So we write them in this order. So EVP plus 9, this is 4, that's 5, that's 6, that's 7, that's 8, that's 9. So D6. I was right that time around. Yep, okay. So that's 9, that's A, that's B, that's got to be C. I don't need to, man. This is about offsets right now more than anything else. Push that first, then that, then that. I'm not convinced about this this line here, Delil. I think your offsets are wrong. Yeah, clearly that's what's killing me. But I don't want to go and cheat and punch it into something. Like that's kind of the point of doing it. Force us to learn to get these things correct without the use of just punching it into an assembler and seeing what the assembler does. So C is definitely 12, right? So I would have thought that that would be that. The first argument is at offset 8. Really? Okay. So I did need to shift back one. Okay, first argument. So this starts at EBP plus 8. Which means this is EBP plus C. So that's going to be A5. Like what we had here. EAX is definitely 0. So we end up with that in EAX. Then the next byte along is D6, right? So we add D6 to AH. Oh, yeah. Okay, so that's right. And what I had here, this thing here is wrong. Okay, so that means that's got to be D223. Is that what we're saying? Yeah, okay. Righto. So to recap then, yeah. So I was originally going off EBP plus 4. It's not, because we've got EBP, which is the previous ESP. And then we've got the return address followed by the arguments. So EBP plus 8 is where it starts. So this is definitely still nonsense, but we need to go EBP plus 12, which goes to the beginning of the second argument, which is A5. So what we do is we take that off and we get 5B in AL. Then we add D6. And then, yeah, my offset here was wrong. I was still reusing the upper bytes from here when I should have gone to here. Okay, that makes way more sense. Yes, EBP plus 4 would be red. Save return pointer. Thanks, Delil. That was helpful. You are correct. Our offsets were definitely wrong. Okay, so that makes more sense. Thank you for the help, people, and the patience. Ooh, we've got a web one. Just so we look at the web. Oops, I just accidentally refreshed. I think I've still got Burp running over here. Cool. 56517. What do we got? Another sub. Rusta! Rusta, I didn't even know you were there. Thank you for the sub, my friend. Very kind of you. Ooh. Failed to connect. 56517. I wonder why that is. Oh, we're actually going direct. We're not even going through Burp. Is this another web challenge that's offline? Doing good, Rasta. Doing pretty good, mate. How are you? Let me just get rid of some of these. Yeah, so it looks like maybe the web challenges at the moment are offline because you are A-OK. That's awesome. Is anyone else able to hit these problems? The web ones? We had a problem with the web one, I think, before, didn't we? Yeah, this one here was also dead. So... yeah, it's just not... oh, hang on. No, that's not it. That was one we owned before. 56517. It looks like the web one's dead. That's a shame. What else can we do? Keygen me? Should we do the keygen me? Can you generate a valid product key? Or should we look at a general skills one? I'm skipping crypto as well. Take your pick. More pwn. Ethan Cruz, more pwn. Everyone loves the pwn. So is that going down to this buffer overflow 3? Is that what you're suggesting? Yeah, this is 2018, the breadstick, exactly. This is deliberate. I started doing this when 2019 was still being run and I didn't feel that it was the right thing to do to live stream it. Have at least 4 pwn pending. So, alright, 2 votes for pwn. We'll do this binary exploitation one then. I do love me some binary, not gonna lie. BO3. How do you get no check certificate? Right, we get the program in, we get the source. Pleasure. Look, I'm in the same boat. I'm doing the other ones for the sake of everyone else's benefit who wants to see it, and because it's something that I'm shit at. I'm shit at most stuff, but you know, I do love the binary. Okay. Nope. Okay. Binary BO3. We got half an hour to go. Alright, let's see what Vuln does. Whoops. Vuln. Let me just do that. Vuln.c. There we go. Okay, let's have a squiz at what this does. Obviously, we've got this win function again, which reads stuff from a flag file hidden behind the scenes. Let's have a look at which order this goes in. We call read canary. Read canary. Read canary reads canary.txt and stores the canary in canary size. Canary size is 4. Okay, so it's reading a 4-byte canary. And it's making sure that the canary is on the stack. So, okay, so this is a classic pretend to be a canary. But I would assume that this is actually pretty easy to automate against because yeah, okay, we know what we can do here, hey. Alright, so let me walk through what's going on in my head. So this vulnerable function has a buffer, and this buffer is a 4-byte buffer that when the function starts is populated with this global canary value. And the aim here would be to have that canary at the bottom of all of the local variables that are on the stack. So if any of the local variables above the canary are overwritten, then when we get down the bottom here, we can say, hey, has the canary changed? And if it has changed, then smash the stack. We get an indication that the stack has been smashed and we bail out. At which point, if we were able to overwrite the save return pointer with, for example, win, then it wouldn't work because we would end up with this exit being called. So we want to be able to detect what the canary is so that we can overwrite the stack values with the actual canary value and just keep on writing past until we overwrite the save return pointer. So the good thing about this clearly is that the canary is exactly the same every single time. So as a result, what we can do is we can figure out what the canary is by brute forcing the bytes. So for example, if we were to do it locally, well, we would need to first of all create a flag.txt. So flag goes here. And then into canary.txt, we'll just go A, B, C, D. No, we'll go W, X, Y, Z. Okay. So if we go vuln and we're going to write, what does it say here? How many bytes do you want to write into the buffer? How many bytes will you write into the buffer? Okay, so on the server you might not have permissions to read canary.txt. Exactly that. So we're not going to be able to read the file. So we're going to infer it by brute forcing, yeah? So buff size is 32 bytes. So that's just going to read %d. And then it's going to ask. So let's just say we're going to give it 32 bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oops. 9, 10, 11, 12, 15, 16. And we'll just double that. Okay, now where's the flag? Hang on a second. That made no sense. Because the global canary, we shouldn't have seen that. Gee, hang on. GDB vuln. That's bizarre. Shouldn't have seen that. Actually being the canary. Yeah, I know, right? So we're going to give it 32 bytes. Yep, that's fine. Oh, hang on, it doesn't override anything. So this is interesting. Oh, okay. So that makes perfect sense. That makes perfect sense because what we should be doing is running and going 64 bytes. And this is where we should see stack smashing detected. Okay, that makes more sense. So we have actually overwritten the buffer. So what do we got here? We've got length and buff. Oh, so that's, jeez. We need to figure out just how far down we need to overwrite for the canary to be deemed to be wrong. I'm assuming that if we run this and instead of 32 we just go 36 bytes. That didn't do what I wanted to do. 36. How many is that? That's 32. That's 36. So yeah, I guess this is interesting, right? I'm just trying to figure out, like, we've got two 32 byte buffers here and we need to know which order that they're in on the stack. So let's do this. Break on vuln. And let's just run now. Actually, BC star, BD star, sorry. Disas vuln. What I want to do is get to the point where it says read, which is just here. Okay, let's run. I'm going to give it 36 characters. Okay. Now let me just go A times 32. Oop, wrong way. So that's 32 characters. So I did have it right before. So 32 followed by 4 more. Okay, so let me just move this down here a little bit. Let's have a look at these two. So here we go. So I have overwritten the canary with the bees. So that implies that the buffer is immediately before the canary, which makes sense. Okay, so basically what we need to be able to do is automate the running of this thing in such a way that we know that each time it succeeds, we will be able to infer one of the bytes from the canary. So let's just move this over here. Stream Pico binary bio3. Now we are going to need to do this on the server as well, but let's just pump it in here and see how well we go. So let's just go cat into solution.py hashbang user bin and python 2. We're going to import pwn. We're going to p equals pwn.process. Here I'm just going to go vuln directly. And then we will, what are we going to do? Chmod plus x solution, and let's gvim that solution, move that up there. Okay, so like we said, we know that we need 32 bytes of junk first. Okay, so we'll just have a buffer which starts with 32 A's. Okay. Our canary at this point is going to be blank. So what we want to do for each time we run this, we actually have to rerun it every time. For character in range up to 256. So for every single byte, we're going to go C equals CHRC, right? We're going to go in, hang on, we'll call this padding. We're going to go buff equals padding plus canary plus C. And we're going to go, we're going to kick off an instance of the process. And we're going to go p.recv. We'll just read whatever it gives us because we're not really that fussed. p.sendLine. We want to give it the length, don't we? We need to go the string of the length of the buffer. So we're going to send it the value of however long the current attempt happens to be. And then from there, we need to p.recv again, because it's going to print out the word input. And then we're going to go p.sendLine buff. Now, what will happen is each time we loop, it will... what is it going to do? It's going to append the new character to the end. And if it doesn't crash, then we can assume that the canary print p.recv. We'll just read another 100 bytes. So if we have a look at what goes on here, whoop. See how we got this stack smashing detected? So what we need to do is go if stack smashing in p.recv. So we know that we've crashed the process, right? Actually, we want to say if not stack smashing, then we need to go buff. No, we don't. We need to go canary plus equals C and then break out of the loop. And then here we can go while the length of the canary is not 4, do this. Does that make sense? Yeah, read if output doesn't have exactly. So if we do that, at this point we should be able to go print. Let's go pwn.unpack. Sorry, it's U32 of canary. And I'm going to hex it. There we go. 57585958. So that's exactly what it is that we need to do. And then once we've got that, we need to kick off another instance of the process. And this time we need to go info function win. Is it win? Yeah, win. Okay, so win equals this. So we can just go canary is now we just need to go buff equals padding plus canary plus, now we know that EBP is going to be next, so we can just put 4 A's followed by the pwn.p32 of win. And then we want to do this again. Actually, let's just do that. And then go p.interactive. Yeah, cool. Okay, well that got EOF, so we did something wrong there. Maybe I got the offset wrong. Oh yeah, canary. Actually, you know what I'm going to do is I'm going to cheat. Let's do that like 4 times. It might need to be more than that actually. How many times? Let's just do that. Oh, we know that's right because we've got another buffer, haven't we, somewhere? We've got like a length buffer, etc. So let's get super lazy and do that. Hey, there we go. And because we've rocked to glory, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we only need 5 of them. There we go, 5. Boom. Okay, so we need to take this, stick it on the server. CD make temp. Make temp D. Cat into solution py. Okay, chmod plus x solution.py. Now we need to do the OS thing again, don't we? Where is it on the servers? You'll find it in here. Okay, so if we go os.chdia to here, then from there we should be good. There we go. There's the canary and there's the flag. Winner, winner, chicken dinner. Huzzah! Hooray! Shells. Yeah, pretty cool, huh? Just goes to show how bad static canaries are. You can always figure them out. Let's see. Do you reckon this web exploit one? We've got 10 minutes. Ooh, this one actually works. Store is kind of fun. Is it now? We even have source. Yeah. Let's take this. May as well start looking at it, right? No check. Let's just have a quick squeeze. Let's close all this nonsense down. Exit. Web store. Well, let's have a look. Ah, it's another Flask website. Of course it is. So you've done this one before then, Le Breadstick. App.run. Flag, logout, login, main. Okay, so we render main. Sorry, the admin password is super secure. You're not getting in that way. Okay, so if you try and log in as admin, you're just going to get a fail. Recipes, make response, redirect flag, cookie. Cookie admin is 0, print cookie. Cookie data equals. Script cookie data, set cookie encrypted. Okay. Okay, that's interesting. Righto, so what have we got? We are encrypting stuff and putting it back in, or pulling it back into a cookie, right? Let's poke this through burp from now on. Let's see what burp says. Okay. So if we try and log in as test, never save. So here we go. Success. You logged in. Not sure you'll be able to see the flag though. Username test, password test, admin 0. So I would assume that the cookie that we are given in our response, this is like a base 64 encoded version of the encrypted shenanigans. And because we pass in this cookie value here, it gets decrypted behind the scenes, and in the source it says when we get to flag, it decrypts the cookie, and if you're an admin, then it will render the flag. And the flag value, where does that come from? Flag value, okay. Yeah, okay, so that's hard-coded in the app and we can't see it. So we have to come up with a way of being able to poke a value into this cookie. Let's just make sure, yep, so B64 encode. Yeah, okay. Everyone can see what we need to be able to do here. Okay, so what ideas have we got? I don't really want to brute force. We're using cipher blockchaining mode, so it's not like we can, there's an ECB vulnerability where blocks are repeated. Secret key is removed, so that's what we're using as the key. It's the MD5 of that key, which is 16 bytes. Thoughts, anyone? What are you guys thinking? Am I flying solo? I guess I am flying solo. Got notifications going bonkers behind the scenes. Geez, I'm glad I put all my streaming stuff inside a VM. Have you done store before? It is not possible to assign the admin flag to 1. That's exactly what we're trying to do. So what I would assume is that if we look at burp, this is an encrypted thing. We need to encrypt as well using what is effectively the secret key and put our own stuff in that indicates whether we're admin or not. The thing is that when we log in, see we've got we can set password, we can set username. We can't set the admin flag. So we need to be able to infer something. Done store, but I think you're working on secure login. Are we? Is that what this is called? I thought it was called, so I just took... Oh yeah, secure logon. I called it store because, you know, I saw what you said and I was let's do store. But yeah, I don't know. I don't know. I'm pretty crap at this kind of thing. But the way I'm seeing it is that maybe we can use the encryption routine as an oracle of some kind. So if we can, specify a username in a certain way, that we can infer what the key is based on what we get back. But I don't know whether that would be the kind of thing that would be done at this level. I mean, how close are we towards the end of all of the challenges? Yeah, I don't know, maybe. But yeah, I mean, all we've got is the cookie that's coming out, right? Which we know is a blob of encrypted data based on what we're seeing in here. Yeah, because when we log in, we set the cookie to the encrypted value that comes out, which is a base 64 encoded version of the cookie data, which is just a dictionary with this. So we want to be able to control this and post that back in, right? So what ideas have we got here? Any ideas? I'm really not sure. Is there some... See, I was under the impression that cipher block chaining mode was the go-to mode to use. If that makes any sense. Does that make sense? Hello? Yeah, we can play with the cookie data. So let's say, let's do this. Let's just throw this at repeater for a minute. Now, this is the cookie. This is the encrypted info. Let's send this to decoder. We know that that's base 64 encoded. So this is the block of crap. Bit flip. Bit flip? What's bit flipping? Is there a bit flipping attack, is there? That's news to me. Sounds like more of a crypto related challenge than a web challenge per se, which I hate. God, I hate crypto. Well, okay, so if we're going to do that, I'm going to have to go and Google. Flip a bit to change the 0 to 1. Oh, okay, so... Oh, I see what you mean. So we go through the encrypted bits. And we only want to flip just... That makes perfect sense. Rasta? Okay, so does that mean... So if we look at the web app... Cookie, username test, password test, admin 0. Okay, so... Does the order matter? Like if we sign in with nothing... I guess we've got less data to muck with. Okay. So what we're saying then is, if we take this cookie here, let's send this to decoder. So we're going to take this, and we're basically going to, for each bit in the whole thing, we're just going to repost. Yeah? Is that what you're saying? Can you do this in like Intruder, in Burp? Is that a thing you can do? Is there like a bit flipping attack? It doesn't care about the contents, username, password, or everything is a string still being admin and the number to be 1. Yeah, exactly that. So that's I think effectively what Rasta is alluding to there. So we could just... Hang on, let's do this. Let's go back to repeater for a sec. I'm going to send this to intruder. So what we want to do is we want to change, we're going to clear all of those, and this is the only thing we want to change. So let's add that one. Payloads, payload set. Is there something in here that's... Well. Intruder has a bit flipper. Okay, so operate on a specific string. Encoded, okay, encoded as ASCII hex. So that means I need to do encode as ASCII hex. So I need to take this. And we need to put this in intruder. Encoded as ASCII hex. Set, yep, do all of them. So when it does this, crest count 512. Yeah, that's interesting. Okay, so is this smart enough to go through every bit in the whole string and just crush it from there? This is new. This is new to me, people. I am not familiar with this. I assume we're going to get a valid response at some point when we flip the right bit and don't break stuff. This might take a while. Well, it won't know, but we will, because we're getting 500s, and I assume that if we flip just a single bit, which is the only thing we need to flip, the response will be not a 500, because I would assume the response is like, hang on, I'm unable to decrypt what you've given me. So it's just going to go through and I assume it's going to go through and flip every single bit individually. I hope. Oh, it's only done 512 and it's stopped. Okay, so that's... Can't remember how to terminate a window in i3. Okay, so I'm clearly doing something incorrect. Maybe I need to do something here. Yeah. How do I close a window again? I'm hopeless. i3 config. Where are we? Kill current window. Q. There we go. Alright, so like clearly I'm doing something wrong. Like we want this payload type operates on an input and modifies the value of each bit position in turn. It can sometimes be used to meaningfully modify decrypted values of CBC encrypted data and potentially interfere with the application logic. Base value of payload position. Okay, so if I do that, that's the same as me specifying this in the body. So that's fine. I'm assuming we're going to have to do more than this because at the moment it's saying there's only 512 requests that we're going to do. I need to process the payload to make it base 60. Ah, yeah, I do, don't I? Add substring, modify case, encode. So I need to encode. hang on a sec. We need to decode it first, right? Decode from ASCII hex, and then we need to encode it as base 64. Yeah. Encode base 64. Yeah. Oh, there we go. And decode hex first. So we decode hex first. Yeah. Okay. Let's see what this does. We'll have a look at some. There we go. This actually looks like it's changing. There are bits changing. It's a good sign, at least, right? The value looks like it's being modified as we go. You can see there is a bit being flipped along the way. You see that? Oh, I've learned something new. I didn't know Burp could do this. I was about to go and just hand code something. Got to be getting close, surely, towards the end. So why is it failing though? I would have thought that at least one of these things would have successfully decrypted. So if it's going to be successfully decrypted, did I miss one? Yeah, good question. I want a base 64 and encode it, but that should be okay. I don't think that's going to be a problem. We can check though. So let's go to repeater. If we just change that to %3D. That was okay. And that was internal server. Okay, so we need to stop that from being URL encoded. So maybe go back here. So base 64 encodes. So let's see what this does. Uncheck URL encoding at the bottom. Oh, yeah. Thank you. URL encode these characters. Let's not do that. Okay. Ooh. There we go. We got some 200s. Not sure you'll be able to see the flag though. Okay. That's a good sign. Thank you for that URL. Ooh. That's a different size. Hey, here it is. Boom. Right, flip all the bits. Okay, there you go. I've learned something new. Okay, so you can actually bit flip against CBC and modify the content of stuff. That's fascinating. Thanks all. I would have taken a long time to figure that out. There would have been a lot of Googling around how to, what the attacks against CBC were and all that sort of thing. But yeah, that's kind of funky. Let's submit the flag. Secure login. That is correct. Well. Yeah, that's kind of funky, hey. I like that. I had no idea that was even a thing. I've got a Christmas hat on. That's hilarious. How did you do that? Did you just go and make that yourself? So good. I was actually thinking of putting a Santa hat on. Channel points. I don't know what channel points are. Is this a new thing? You pick an existing emote and you can make a generic modification. So, wow, I had no idea. That's very cool. That's very cool. Well, you know, there's a couple of challenges there that I wouldn't have got through if I didn't have help. Certainly not in the time frame that I was given, but that's really fun. That bit flipping thing is definitely a new thing to me. I didn't realize that was a thing that you could do. There's things like sunglasses and reindeer horns. Yeah, nice. Well, people, it's 20 to 10 my time, which means we have reached we've actually gone over 2 hours and 10 minutes. A 2-hour limit was intended. So at this point, I intend to sign off, and I'm going to go and put this video up on the tubes for those people who live in obscure time zones so that they can watch the failures later on. But as always, it's been wonderful having you guys and gals playing along and helping me out, and we're all learning and enjoying together. It's been great. I'm sorry again that it took me so long after that month of various other shenanigans, but you know, really, really great to have you all back, and I really enjoyed it, and I hope you guys enjoyed it too, and that you learned something. And I'm not sure when the next one is going to be. I might be able to squeeze one of these in between the Christmas Day and New Year's. It just depends on family commitments, but I do plan on getting stuck into it at the very latest back at the beginning of January. But I just want to say I'm really grateful. An Xmas Day stream. Never gonna happen. I'm really grateful for everyone who supports me in all of the different ways. Like that's you guys who are constantly sitting here talking to me and helping me out on stream with things that I fail at doing. It's the fact that you're all awesome to each other, and there's very, very few people that come on here and misbehave. Everyone's really good spirits, and it really does make the stream good. You guys are what make the streams really good. I'm grateful for all the financial support that I get through Patreon and from the subs, and just from people publicly, saying nice stuff about what it is that I'm doing, even though I'm kind of winging it most of the time. But look, seriously, this last year has been awesome for streaming. I've had a lot of fun. I've learned a crap load, and it's been great having all of you on. So I hope to see you again in the new year. And yeah, thanks very much. I'm looking forward to it. Oh, and I'll see you at B-Sides Melbourne. I'll be there. Hopefully you'll be there too. But yeah, it's been awesome. Have a great end of year break, whether you celebrate Christmas or not. Look after yourselves. Be safe on the roads. Don't drink too much. Be nice to people, and be good to each other. See ya.